In this second part, we'll perform experiments related to telescopes and telescope setups. The aim is to construct a Galilean and a Keplerian telescope in a very simple manner. In the case, you'll find three lenses: the 150mm convex, the 30mm biconvex, and the -30mm concave lens. The one main difference between the Galilean and Keplerian telescopes is which type of lens is used for the eyepiece. The objective lens is the same for both and always has a greater focal length, in our case 150mm. In the Galilean telescope, the eyepiece has a negative focal length, while for the Keplerian telescope we use the positive eyepiece lens. With the materials in the case, this setup can be used to demonstrate the imaging of very distant objects in the telescope. In addition to these materials, it is useful to have clothes pegs or something similar on hand to ensure the lenses are held firmly in place. For the Galilean telescope, we use the -30mm lens as the eyepiece. The students can work out the relationship between the distances, seeing here that the sum of the focal lengths must always correspond to the distance between the two lenses in the telescope setup. In this case, 150 minus 30 equals 120mm. Although the LED module in the case is well suited for imaging purposes, it is quite difficult to tell whether the image projected is the right way up. In this demonstration, we use a candle flame that makes it easier to determine whether the orientation is correct and the image is upright, or whether it is upside down and inverted. Here you can see the view through the Galilean telescope as we pan past. With the Galilean telescope, we create an upright image with strong magnification, but a very narrow field of view. If we remove the eyepiece, only the objective lens remains in the structure. In the first part of this module, we have already looked at the imaging rules for single lenses and seen that it's never possible to create an upright image with a single lens. In this experiment, the students will reconfirm this principle. If we then remove the objective lens as well, we are left with the normal, real image created by the lens of our eye. As already mentioned, a Keplerian telescope uses two positive lenses. The same imaging rule also applies here, namely that the distance between both lenses in the telescope setup must correspond to the sum of the focal lengths. In this case, 30 plus 150 equals 180mm. Also at this distance, we get a sharp image. However, a closer look reveals that the Keplerian telescope creates an inverted, upside-down image in exchange for a wider field of view.